Hello everyone and welcome to Canteen Cup. My name is Scott and today I want to talk about antennas. Specifically, I want to talk about ham radio or HF antennas and how it relates to preparedness. For all you ham radio operators that may come across this video, this is not a technical video. This is geared towards the beginner or somebody who knows very little about ham radio or about radio antennas. So I am speaking in broad terms. I'm speaking, rather simplistically. It's really just to give people an idea of what either they may need or what their group may need when it comes to talking about antennas for ham radio, because there's a myriad of antennas out there. There's lots of deep math. There's lots of discussion. I mean, ham radio operators like to delve into all the minutiae involved, but really for this video, what I'm trying to do is give the average person who does not know a lot about ham radio or HF radio an overview, and to help them, have at least a moderately informed conversation with somebody else, or if somebody's talking to them, they might have a little bit of understanding what, like, the ham radio operator is talking about. And so that being said, I want to talk about antennas that are designed for the HF frequency range. Now, this is where some of our ham radio jargon kind of gets confusing, because sometimes we talk about ham radio bands as a wavelength in meters, and then sometimes we talk about it as a frequency, as in like megahertz. So without going into all of them, I'm just going to say that primarily for emergency SHTF, WROL type situations, that your main concern will probably be frequencies found in the 80 meter band, that's 80, and the 40 meter band, 40, and maybe some in the 20 meter band, 20. Now, sometimes we talk about those in megahertz. The 80 meter band, or actually we like to say that's the 80/75 meter band, because there's a large allocation down there of frequencies, but it basically goes from about 3.6 to 3.9 megahertz. And I'm not quoting exact, but right there in the voice mode, which is probably where you're more apt to be, it'll be somewhere in the 3.8 to 4.0 megahertz. I know it doesn't mean a lot, but most hams will say we'll be on the 80 meter band. Okay, the 40 meter band is in the 7 megahertz range, and I won't go into the minutia of that. And then the 20 meter band is in the 14 megahertz band. So if you can remember, 80 meters about 3.6, 40 meters say 7.2, and 20 meters say 14.2 megahertz. That'll get you close enough. But primarily what we're talking about today, again as a broad overview, is antennas in the 80 meter band and the 40 meter band. Now, really what the meter stands for is how long a wavelength is. In other words, one complete cycle of a radio frequency is so long. in the 80 meter band, it's approximately 80 meters long, or that could be somewhere around 250 feet. In the 40 meter band, it's about half, about 120 feet, 40 meters. So just to give you an idea of what people are talking about, that's not important. Just recognize that typically for emergency preparedness, you're either going to operate in the 80 meter band or the 40 meter band. And if you are a technician and you're going for your general class or your extra class license, you'll learn more about the different bands. But I wanted to talk about antennas because there's a lot of stuff out there for antennas. And I wanted to touch briefly on, what's the best, what's the worst. And again, I'm speaking in very broad strokes, so to speak. I'm talking in general terms, just to help you in your decisions or to help your group in their decisions that they want to make when it comes to selecting an antenna for your ham radio station. Now, the most common antenna for amateur radio communications in these lower bands, that's the 40 and 80 meter band, is usually a dipole or some variation of a dipole. And for this, you really want to have a resonant antenna. That's really the best. Antennas do not have to be resonant, but that's a whole nother discussion for a whole nother time. So again, for just clarity and for general information, that an antenna needs to be resonant. And what I mean by resonant is that the antenna presents a 50 ohm resistance at the input, or its impedance. And what that means is your radio transmitter operates at its peak power when it has a 50 ohm load attached to it. So just remember 50 ohms. Okay? And so an antenna, when you look at all its components, the antenna itself, the feed line, which is the coax cable that runs from the antenna to possibly a transmatch or an antenna tuner to the transmitter, has to have a 50 ohm load at the transmitter for that transmitter to deliver its full power to the antenna. Now, there's all sorts of discussion about that, but again, we're keeping it simple. When you start to deviate from that 50 ohms, in other words, if your antenna is not cut to a resonant frequency or a harmonic of that resonant frequency, and I'll talk about that in a second, then the load or the impedance changes, and it typically reduces the power that the transmitter can put out. That's a complex subject. So just remember that you want to have 50 ohms at the transmitter, and there's a meter that we use. There's a ratio that we use called the SWR, the standing wave ratio, and pretty much all transceivers that are for ham radio have a way to measure SWR, but you want to be as close to 1 as possible. 1 means a perfect match. You could go up to 1.5, you can go up to 2, but as you start climbing away from 1 is as low as you can go, but as you start climbing away from 1, the SWR goes up, the ratio goes up, and then the power that the transmitter can deliver goes down. Again, a broad stroke, and just keep that in mind. So ideally, you want an SWR of 1, and that'll deliver your 50 ohms, and that means whatever power you have dialed into your transceiver will be transmitted to the antenna. And there's a whole lot of other stuff involved, but again, this is very simple. And for you hams out there, I know. Okay? So, that being said, when you go to build your antenna or buy your antenna, what do you want to get? Well, I would suggest that you consider the lowest frequency or the lowest band you want to go to and get an antenna that size. Now, what that means is the lower the band, and it's kind of backwards. An 80 meter band is lower than a 40 meter band. Okay, so if you want an 80 meter, if you plan on talking on 80 meters, and that's, that may be the lowest you want to go, then you want your antenna to be tuned to an 80 meter band. And what I mean by that is the lower the band, the bigger the antenna, because remember that wavelength goes up. 80 is bigger than 40, but it's a lower frequency because the wavelength is longer. So we talked about emergency communications or, SHTF type communications, and they will probably be in the 80 or 40 meter band. Now, what does that mean? Typically, when you make a dipole for a certain band, you use what's called half wave, or half of the frequency. Now, I said that an 80 meter band, is really somewhere around 250 feet or 260 feet, right in there. I didn't do the calculation. And so if you're going to have a half wave dipole cut for 80 meters, then without showing you all the calculations, it comes out to about 132 feet. Okay, if you do the math, that's what you get, about 132 feet. Now, why not get a smaller antenna? Well, there's a couple problems. One is, the smaller the antenna, the pickier it gets to tuning, and the usable bandwidth is smaller. That's called Q. It's a higher Q, and it gets smaller as you get an electrically smaller antenna. So really, you want to start out big and then use that for your other bands. An example is 80 meters is about 132 feet. A 40 meter antenna is about 61 feet, give or take. And so what that means is you have a full wave antenna for 40 meters if you use an 80 meter antenna on 40, which if you went the other way, an 80 meter frequency on a 40 meter antenna, it would make that 40 meter antenna a quarter wave. It would make it electrically smaller, and the signal's not as good. So just remember, bigger is better. You want the biggest antenna you can put out there, and I will tell you a quick story about this. When I was up in Northern Virginia, we were doing some experiments with antennas and how we can hear in and through the mountains. I had one guy set up to one side of me about 5 miles away, and he used 2 ham sticks, set them up kind of like a dipole, but a ham stick's only about 7 foot long. So he had a 14-foot antenna, okay? And then on the other side of me, I had a guy that set up a big loop antenna. It was about 600 foot long, and it was about 20, 30 foot up in the trees. And so the guy with the 2 ham sticks was putting out 100 watts, and I could hardly hear him. He was very faint. He was what we call down in the noise. In other words, the normal static, he was mixed in with that. I could hardly hear him. On the other side of me, the guy with the large loop was only running 5 watts. And I know this because he had a radio that can only go maybe up to 10. But his signal came booming into mine, probably about 50 times the power of the other guy. And so power isn't everything. It's also the antenna. And these guys were about the same distance apart. We had about the same type of geography between us. So if everything was equal, I should have been able to hear them both about the same. But because this guy over here had such a small antenna, even though he was putting out 100 watts, I could hardly hear him. Whereas this guy over here had a big antenna, and he was only putting out 5 or 10 watts. I could hear him like he was, standing next to me. So that's why it's important to have a large antenna, the biggest one you can get. Because when we get into if we talk more about, power and batteries and such, you may not be able to run 100 watts all the time. You may have to cut your power back to conserve your energy. And so having a bigger antenna is a big multiplier when it comes to how much of your signal gets out and where it goes. So again, this is just a brief overview, talking in broad terms. It's just to give you guys a little bit better idea. When especially a ham radio operator, talks about antennas, we tend to go into our jargon and we talk about all the different things. But really what you have to remember is you're more than likely going to be down in the 80 meter band or maybe the 40 meter band. And having an 80 meter antenna makes a 40 meter transmission twice as good, where if you go from a 40 meter antenna to talk on an 80 meter frequency, it's only half as good. So ideally, you want a dipole that's cut for 80 meters, and because 40 meters is a harmonic, it'll work. 20 meters is a harmonic of 40 and 80, it'll work. And then even 10 meters, which is a harmonic, will work. Your antenna tuner will tune all of those. So go large. Go big or go home. And that'll help you get your signal out. It'll also help you with your listening. Well, that's all I got for now. Like I said, it's just a broad stroke just to get you thinking. So don't get inundated. Just remember, when it comes to antennas, bigger's better. We'll see you out there.